Asif, good evening. Shubham, good evening. Gokul, Rahul, Sushil, Sonali, Bhargavi, Sumit, Ritik, Nishita, Abhinay, Suraj, Dhanpal, Sadbhavana, Chaitanya, Lallu, Chanikya, good evening. Deep, Amitabh, Rohit, good evening. Anupama, Deepak, Matthews, Namaste, Robert. Happy Eid. Eid Mubarak, bhai. Jai Hind, Rudraksh. Today last here also festival is delicious food only. No. So Monday onwards you need to see me 2 times deep, morning and evening also. Thank you. Think I need to adjust the light. Just wait. Light what discussing. Okay. Data transfer group of instructions. Now in the data transfer group of instructions we have completed today's doubt session. Now I will make it regular session on. Maybe day after tomorrow or somewhere we take the doubt session. Why? Because I gave 2 DPPs. I will give you today also time. Then we can do it. Okay. Tomorrow in the sense, tell me. Good evening, Lucky. MVI R, 8-bit data. Next, move R, M. Move M, R. So these 4 are completed. Now let's move to the next instruction. Okay. So the next one. Lallu, you were there yesterday? Yeah. Then what is your doubt? We have completed that yesterday. Move and MVI. Move immediately and move register and move whatever we discussed. I for immediate. So now come to this load accumulator with the 16-bit address. Any issue? Remaining people, please tell me. Nothing is there. Just refresh it, Ankit. Just refresh. Okay. So see here. LDA 16-bit address. LDA 16-bit address. Fan noise is more. Shall I switch off? Instruction accumulator is copied by the contents of 16-bit address directly specified in the instruction. Okay. All right. So now so if you say forget about this, don't read this. Let me explain the things properly. LDA 16-bit address. What it will do? Let's take one example. load accumulator with some 3000 hexadecimal. If I say like that, what happens? In this case, what happens is first we should say, I will explain it, just listen. First, you should write opcode, then you should write 00, then 30. Then what computer will do is load the accumulator, okay, load accumulator with the contents of the memory pointed by the given in the instruction directly. Directly we have given the address. Computer will go there, okay, and in this location, whatever you are having, what is that 3000 may some data is there, some randomly you take any number, say 56 or anything, what is or 45. This should be loaded into accumulator. So computer will do what? Accumulator will be copied with the contents of 3000. What is the content of 3000? 3000 is the address, content is 45. So accumulator will be copied with 45 hexadecimal. 45 hexadecimal. Now this is opcode fetch. You tell me what is this operation next? Mr. MR. MR means whatever it is there, it will store here. Sura. It can be garbage value also. Another memory read. Okay. And here, what we do? This is also read from memory only. Memory read only. But here, when it reads now, who will load these values? Because computer should go. We means you will be loading it there or what? I'm asking Ganesh, please see. Not PC, not PC, not PC. Your W and Z register will take care. Okay. So during this memory reads the machine cycle, your address bus will be copied with whom? WZ. Okay. Address bus is copied with the WZ. This is the first machine cycle. In the second machine cycle, what happens? That contents are copied into data bus. Then third machine cycle, accumulator is copied with the data bus. These are the things happens here. Yeah, most of the cases. If something different here, I will explain. Okay, because here program counter will not go there. Program counter will be staying here only. It will continue its operation after this also. After this also, program counter will continue from here. It should not move every time from here to here. Okay. HL has its own purpose. We should not use it. HL, BCD. Why not we use BCD? Because they are having some data already. Maybe here you are already used something MVI H comma 25. If you use H and L, here H and L will be disturbed. So we should not disturb any register here. That's why only what temporary registers will be used. Programmer may be using that H and L. Okay. Without PC, how will you move from here to here, here to here, here to here? Program counter will take care of the sequence of the program. Okay. Clear? We should not disturb other registers. They may be already having some data. They may be used in your program by some other instructions. We should not disturb them unless it is a part of program. Yes, correct, Sonali. Not any temporary registers. We have only two temporary registers, W and Z. Another temporary register is there that is used for ALU operations. That also we discuss it. No, that's what I said, na Shivam. Suppose this is your address. Okay. Here it is 4,000. For example, just randomly or 2,000 you take. This is 2001. This is 2002 and so on. So here your PC will be loaded with 2001. Here PC is loaded with 2002. Every time when the program is being executed during the T2 state, program counter will be incremented. It will be moving to the next. Here it will be moving to the next. Now also PC will be readily waiting with 2003. But the next machine cycle is not opcode page. It is memory read from some other place because computer knows here. Computer knows here. Here address bus is not copied with PC. Who is copying it? W. So after this again, after this total is completed, next will be fetched from 2003 only. Whatever you are having. Okay, clear? Why pipelining is required here? There is no execution overlap. Where pipelining is happening here, directly it will load to Z. Here directly it load to W. Then WZ will load to address bus. Address will load to data. Execution is not taking place in the next instruction here. It is taking place in this instruction only. How many machine cycles? Let's calculate. Okay. So wait. Good. So firstly, you only tell me. Why should I say? You people know better than me now. How many bytes of memory is required to for this instruction? 3 byte. Just 3 byte. Okay. And each instruction may how many machine cycles? 1, 2, 3, 4. This fourth is also part of this instruction only. Okay. So total 4 machine cycles. Just wait. Just wait. You may have the doubt, sir, why can't we take this fourth machine cycle as first machine cycle of next instruction, sir? Because it is a memory operation. Your bus is required here. It is not internal operation. You cannot overlap this. If it is internal operation like addition or register to register transfer, there you can do the overlap of fetch execution. But here it is not possible for 8085 architecture. Okay, good. So right now where we are, right, 4 machine cycles are there. Yeah, no need means here not possible, not no need, not possible in this particular architecture. Okay, how many machine cycles are opcode fetch, memory read, memory read, memory read. So 4T plus 3T plus 3T plus 3T, 13T. Then okay, what is the addressing mode? You should say directly address is given in the instruction. What is the addressing mode? What is the addressing mode? Very good. Directly. Immediately data is given, that is immediate addressing mode. Here direct, not register direct, simply direct only. Direct addressing mode. Directly address is given in the instruction. It is direct addressing mode. You people are not revising yesterday's class before coming today. Some people, please revise it, otherwise it's of no use. Every class is having some link with the previous classes. So lastly, anyway, you know the last line which is common for all. Anyone having any doubt, feel free to ask. Sir, T states not getting. Abhinit, what is the problem in T states? Opcode fetch requires 4. Any memory operation requires 3. Simple. Contents means what is there in the memory. Aditya. Wait, let me check other. Rahul, what is this? This part, this blue color part is your instruction. How much size is required for instruction? I'm not saying outside part. In the program, this is your program. This is external part of the program. In the program, how much size is required? That's all. Next, states. Abhinit, now your doubt is clear. Rahul, clear. Aditya, any doubt? Aditya doubt also clear. Anuj, sir, after 3000, the operation stop and we'll move to the, yeah, after three, not after 3000. After this memory read, where here computer will understand this requires 3 memory reads. After this, next it will read its opcode fetch from the PC. LDA 36 is not there in 8085. Okay, it should accept its format only, not every format of our wish. Good evening, Gopi. Yes, Aditya. Okay, Amitabh, that is not there. LDA 3000 is there. There is this format is not available in your 8085. No LDA 30. That business is not there. Instead of that, you can say MVA A, 30. Exactly correct. Data bus will not go anywhere. Okay. Address bus will go. Data is loaded from the address bus. Aditya, the problem with you is you are not following yesterday's class. I told this logic yesterday. Those who are in the class, please tell me whether I told it or not. Huh? So don't come only to the classes and leave the class. It is of no use for you people. Revise the things. Okay? Yeah, it is possible. Aman. Okay? See here. Your data bus is there now D7 to D0. This will be copied with the contents of 3000. I am not saying D7 to D0 is copying with 3000. It is not possible. This is possible. What does it mean? Contents of this location. Whatever you are having, this value will come. This we represent like this. LDA should be followed by address. If it is not followed also, computer by default takes next to 2 bytes as its address. Why LDA 30H here? You have MVI. Already MVI is there. It is not your wish or my wish. It is according to the syntax of the program. Okay. Of code. Whoever designing, he will fix it. What is the purpose of LDA instruction? LDA instruction, please listen, is to load data from the memory. To load data from the memory is of 16 bytes address. So compulsory you should have LDA 3000, not 30. LDA 0030 is definitely there. What is the problem? Happily there. But 00 is also on one number only. Don't take 00 means I will write 30. It is of no meaning. Okay. 0030 is the same as 30 for you. Yes, Harsh told same thing. Okay. Not for computer. How computer will understand all those things? Yeah? Whatever its method is fixed. Okay. Now present days there are so many things. If 30 comes automatically, it will assume with 2 zeros. Like that you can design the things. Whatever I discuss, Ganesh, up to this, whenever it is being used, I will explain that. Don't worry about it. Okay. So shall we move further? So if you have LDA, you will also have STA. What is STA, sir? Load means loading the accumulator, keeping it in the accumulator. What is store? Store means what? What is store accumulator? Reverse. Store means here, load means load into accumulator. Store means store from accumulator to memory. Yes. It's the reverse job. Let's see. Let me keep this. Where are we? Store. Store. Let me import. Good. So let's see what is this store accumulator. It is just a reverse job of load accumulator. Let us see what happens. Please listen, stop the discussion. Now, for example, shall we take the same address? Store 3000. So 3000 is the location which is having some number 25. Okay. So now what I will write? I will be writing opcode and 30. So some address. This is the address. At any address 2000. I'm just randomly taking these numbers. So computer, what it will do? Accumulator will be copied with the contents of 3000. Contents of 3000 means it will not load accumulator with 3000. It is impossible. Okay. As so many are asking again and again, what is accumulator now? Contents of 3000. 25. Okay. Now see here. First opcode page. Then memory read. Now here also it is also. Why I write memory read here? You didn't say anything. Here memory right time. Sorry. Wait. This is not memory read. What is this? Yeah, accumulator to memory. I'm sorry. What happened? Right. So Monday morning we are meeting again. Very freshly. I'm in the weekend mood. Network. So Monday and onwards we need to wake up early every day. Yes. Night time we need to start sleeping in. Okay. So whatever. So assume accumulator is having some number 45 hexadecimal. Okay. So in this case, what happens? Accumulator will come here. Accumulator means actually accumulator will give to some register, any Z register or something. Or first accumulator will give to the data bus. Okay, what happens here? And now that content, this will be replaced by, overwritten by accumulator value. Accumulator is having how much? 40. 40. So this is a memory write operation. Memory write operation. So now it is same. What is that? 3-byte instruction. Okay. What is that? 4 machine cycles opcode fetch plus 2 memory read plus memory write. Same as previous case na 13 states. What is the addressing mode? Direct addressing mode. Direct addressing mode. Direct addressing mode. No flags affected. No flags affected. Is it okay? Fine. What will be the opcode of this? If you want, we can generate it, not an issue. Okay. Whatever for store, you will be having some format. We can see that we need to check that format, and I think I have made that also. If you want, I can show. Yeah. Is there any store kind of thing here? Exchange, LXI, XCHG, HL, VCD, HL, all others. Okay. I don't have that. It's not KMap here, just a table. Okay. One way you can say it is a KMap representation, but originally it is a table. Actually, for move, we know the code. It is 0. These destinations, you should also think. You are very logical. What is the meaning of D? What is the meaning? What could be the things? You should think. Okay. So for store, I don't have. I think if you want, I can get that, but not in. It is not required for us. It will come under either this one or this one, because it is not move or exchange or LXI. It is any one of them. Okay. So actually we can make it. It is 0 0. Let's try. Let's try a hit whether we will get it or not. Okay. Load accumulator. Accumulator means how much? Accumulator is 111. We are not sure. I'm not sure whether I will get this or not. 39. Okay. Don't worry, Amtabji, it is not required. Let's for fun, Amtabji. Where is the top code yesterday I have uploaded? Where is that load accumulator? No? Actually, for load and store, there should be some difference. So maybe our answer will not be correct. Let's check. Or we can do reverse engineering. GHIJKN. LDA is 3A. It is 3A. Okay, 3A means 0011 1010. So first part, this part is correct. This is 010. Okay, load accumulator. My last destination should be 010. Why it is 010? Source is a address. Maybe for address it is 010. No, not like that. It depends. Every time this will change. Every time this will change. If it is 01, then only that coding. Okay. Here, see, if it is a register pair, the coding will be different. For a register pair, similarly for a direct address, the coding will be different. Okay. So let's leave it. Don't worry much. So generally, maybe direct address, it may be 010. Like that, we can make the codes. So not if you require everything we can get, but it is not our importance. So let's move. Let's move. So after store, the next instruction. After LDA, let's see LDAX. What is LDAX? Load indirectly. Load accumulator indirectly with a register pair. Please understand the logic here. Register pair cannot be stored into accumulator. Register pair cannot be stored into accumulator. So what is register pair meaning? Don't read that. Don't read that. Definition should come after explanation. So if I say, please listen. For example, I say LDAX-B. What does it mean? A is copied with contents of BC. Assuming BC is already having some address. Assuming BC is already having some address. So your LDAX is having two variants only. LDAX, where is that? LDAX B is there. LDAX D also there. B means BC. Yeah, B is the name given for BC. D is the name given for DE. Okay. Now listen. What it happens? What happens is, see here. Is there any address or data in this instruction? Firstly, tell me in the instruction, is there any address or data? No. So can you tell me how much memory is required for this instruction? How much memory is required for this instruction? Only 1 byte. It is opcode fetch only. But now let's take this example little further. BC is already having some 5000. This is assumed. Then accumulator will be copied with the contents of 5000. Just for example. Okay, so let's take some memory called 5000. From 5000, whatever it is there, say it is having 33. Computer will be copied. This value will be copied into whom? Accumulator. First databus will give to accumulator. So it is reading the memory. That is, the A will be copied with 33. So here, tell me, how many bytes of instruction? Everybody might by having the confusion, sir, is it 2 byte? No, this is not part of your instruction. It is external to the instruction, so it should not be counted. Only 1 byte. Next, listen. The next one, what is the point? Which point you want me to repeat, Aman? Hey, wait here. How 1 byte? Every time I'm saying the same thing, please be careful. Everybody see here. Only this will be your part of the instruction. This is outside the program. This value can be anything. We don't know now. It is outside the program. Only program will not contain this value. Computer may go here to implement this. That is a different case. But it is outside the program. So for the instruction, we consider only this. Similarly, here also, this is outside the program. Program will be containing only this part. That's why only 1 byte. Okay. Now listen here. So what is how many machine cycles are there? I will come to you, Aditya, 2 machine cycles. So two machine cycles are opcode fetch and memory read. Opcode fetch is 4 T states, memory read is 3 T states, 7 T states में आपका job हो गया. Next. What is the addressing mode here? You are using register as a pointer. So what is the addressing mode? Register indirect addressing mode. Next. No flags are affected. This line need not be written every time. Okay. So now wait. So some Alicha is having the doubt. What is the doubt Alicha is having? Sir, BC can be 5000 also. 5000 can be data also. You use it as a data, nothing wrong. I mean, computer don't know whether it is data or address. You can use this B and C as in the same program. You can use move C comma B, move E comma move D comma B, move E comma C, add D, add E. You can use it as data, you can use it as address. Computer don't know. You are the user, you are using it as a address or data. Please understand, these are the mnemonics. We call it as these are mnemonics given by manufacturer. Anuj. When LDA comes, you should. This is easy way to remember. He gives these names. There is no meaning. Computer don't know this name. Computer know only ones and zero. Okay. So for your understanding purpose, they give the different names like this. LDA, one you see, you understand it is load accumulator. LDAX register pair, LXI register pair, like that. Okay. Load immediately. So these are the codes we used. We in the sense the manufacturer has given to indicate the meaning, to indicate it such that it is easy to remembering, is like that. Exactly, Aditya. So when LDX comes, computer will understand whatever there in the BC, it will treat it as address. Or simply, when LDX comes, BC values will be given to address bus. Then address bus will treat it as address. Shall we move? Okay. If you have LDX, you will also have STX. What is STX? Please understand. 1 minute, 1 minute. I will ask you one thing. Who will do this memory read? Who will do that memory read? I mean, that is copied into accumulator. So address bus is copied with what? 5000 will be given to whom? Address bus, na? So please listen. Here we don't use WZ registers. Here there is no need of WZ registers because address is already present in whom? B and C. Directly BC will give to address bus. BC will directly give to the address bus. Okay. If it is BC, BC. If it is DE, if it will be DE. And one more I want to say is there is no more. Sorry, what is that? LDAXH. Why? I said LDX BD is there, BC is there, DE is there, but not HL. Why? So what? Yes, Rohit. No. Already this instruction is there by the name move A comma M. Yesterday we discussed. We have move a comma m. Okay, not because of LHLD hash, because of move a comma m. Because move a comma m will do a into copied with the contents of it. Okay, is the same. If you want LDXH, A should copy with HL. That is not required. Okay, that is not required. There is no LDX. It is not valid instruction. Move A comma. It is with the name of move A comma M. Okay, fine. Right. Let's move. Your LDX is completed. Let's move to STAX. Questions can be done after arithmetic group. I can give more questions. Only with these, we cannot discuss the questions. That's why we are discussing theory from long. Okay, just keep some patience until the completion of arithmetic and logic group of instructions. Okay, then we can do questions. You cannot make a program with only what we call data transfer group of instructions. Right now, no polars. Okay, so store accumulator. Store accumulator contents into the memory location pointed indirectly by the register pair. Now, it is just a reverse job. Today, we will see, Aditya. If your mood permits and if topic permits, we will extend. Otherwise, we can end by 9. It is up to you people. I'm okay. So, STAX RP. This RP can be, you have two variants in this STAXB, STAXD. Okay. So, listen here. Accumulator will be copied with the contents of the memory location pointed by the register. Okay, yeah, don't worry. Why are you worrying right now about the timings? Okay, don't worry. We will see according to topic. I also want to leave by 9 only. Don't worry. So no polls from long time. So you need poll for this at least. Okay. Yeah, for store I am writing always reverse. Okay, we'll see. Don't worry. Your accumulator will be copied into the contents of the memory. So for example, your BC is already having 2000. Why every time same number? So then accumulator is having some number 35 initial. Okay. Now if I say STAXB, what happens? Accumulator is copied with the contents of 2000. Arey yaar, why I am doing every time same mistake? I'm sorry yaar. Okay. This BC is copied. BC in the sense contents of BC are copied with it. Contents of BC means what? 2000 will be copied with the contents of it. Okay. So now, okay. Now what happens? Suppose you take this as address some 4000. This is your 2000. Okay, if I say this, it will read opcode. And now accumulator value will be copied here. So if you are having some 25 already, it will computer will come. I mean, address bus will come here and do the what memory write operation. Memory write my what happens? This accumulator value. Accumulator value is what 30. Okay. So this is a simple thing it will do. So what is that? It is a 1 byte instruction. 2 machine cycles. Opcode fetch plus memory read 40 states, not 70 states. Okay, 70 states, 70 states, 70 states, and why 1 minute. Opcode fetch plus memory read 70 states. What is the addressing mode? What is the addressing mode? We are concept of pointers, register, indirect. Okay. It is a garbage or dustbin, I don't know. It is the existing value with it. Okay, no flags affected. Okay, let's keep some good name as initial value. Happy, very good. Then where we are, store is done, load is done. Now let's do, because we are discussing a lot of theory, you people may feel some boring, monotony. So let's go a little back. When flags are affected, Lallu, you are waiting for the flags, wait for up to arithmetic operations. Yes, lucky there will be some subject, but I don't know what is that subject. Definitely there will be some subject. Nishita told na some controls will be there. You people are more updated than me. Listen, listen. For example, suppose I want to show you why we are discussing all these things. What is the importance of this? Yeah, okay, you can read all the subjects. Just now first read micro. Okay. So what is the importance of this? What is the importance of these particular things to learn? For example, let's see. Please listen. Suppose write a program to copy contents of accumulator into, or yes, please stop that. Shall I block the comments? Shall I off the comments? Write a program to copy the contents of 3000. Why you written 3000? Somebody asked me 8000. Let's take that. 8000 address into accumulator. 8000 एड्रेस में जो डाटा है वो डाटा हम किसको एक्यूमुलेटर में कॉपी करना चाहेंगे. We need to copy the data in the 8000 memory location into accumulator. So let's see how to do it. How to write a program. See here. Just wait here. Anuj as okay. I don't want to block the chart. Okay, just made this questions off right now, but I don't want to off the chart. I want you comments, otherwise, in fact, it is my weakness. I cannot teach. So just I say such that you don't comment. As long as you comment in the interactively, I mean, with respect to the subject, then only we can teach better. So one, who is that? Who is that? Someone who's told this. So anything else, any other answer is possible. Any other answer? Yes, please tell. With move. How to do with move? With MVI operation, you copy H with 80, L with 00, and then you say move A comma M. Okay, LEXB. Yeah, similar to that Sonali. Move C and B with 8000 and this LEXB also. Move, okay, BC in that C with 00, B with 80, and you can do LDAXB. Why this is wait. Move A comma M. Here LDAX B. Else there is one instruction we discussed next. LXI H comma 8000 and move A comma M. Okay, or LXI B comma 8000 LD AX. Okay, so different choices are there to do a particular job. To do a particular job, different are there. Okay. Yeah, what is the problem in that? It is not LDX. I hope you can see. This is not D. This is letter X. Aditya. I haven't written LDX. If I write it, please show me, Aditya, where I have written LDXH. Okay. Move can come with BC, but what is the use of that now? Now we don't have that use. Na? So listen here. In this case, your job is completed in 3 byte and 13 T states. You know it now? Here, move A comma BC is not there, man. What A comma R1 comma R2 is the format. R1 comma R2 is the format you are having. Okay. Now here 70 states and 40 states. Total how much time? Are 2 byte, 1 byte, 5 byte and 70 states, 7, 14, 14 plus 4, 18 T states. Here also same. So here this I have not discussed, so I am just giving you, just remember. Okay, I will explain that. It is a 4 byte. This is 3 plus 1, 4, and also what I want to say here, it is 3 T states, and this is sorry, 10 plus 7, 17 T states. I'm not this, forget about it now. Okay, just next only we discuss this, don't worry. So now what happens is, as an efficient programmer, when you are having a choice, so when you're writing the program, there are different ways which can perform your program. But as an efficient program, you always try to save your memory, save the time also. Save the memory and also save the time. Why it is okay, save the memory and save the time also. So for that, what to do? For the what to do? Choose the best one. Here, what is the best one? The first one is efficient with respect to time and memory. Sometimes the time may be more in one thing, memory may be less in one thing. Like that, whichever particular application, whatever suits for you, you should choose. Whatever suits for you, you should choose. Okay, now in this case, if BC is 8,000 already, okay, already BC is having 8,000, that is existing. Then 1 byte, how much time? 7. Sorry, what is this time for this LDX? We have calculated now LDX, STX. How much time? 70 states. In that case, it will be efficient. So it depends on your condition. You should choose which instruction is to be written, which instruction is not to be written. Okay. So now you understand all are similar to move operations only. Depending on the question, we choose the particular instruction. As a programmer, always time efficiency we calculate, and also the memory efficiency. Both of them we calculate. Mostly right now, what is that? Time is important, crucial for us. Good. So let's move. Okay. Good. So let's move to the next instruction. Where is that? Good. I need to change the theme. Now, see here, LXI RP, load immediately the register pair. Listen here. What is the meaning of LXI SP? LXI SP means LXI RP means load immediately register pair with the 16-bit data. What you need to do? Load immediately the register pair with the 16-bit data. Let's see how to do it. Let's see how to do it. Say for example, if I say LXI RP, comma 16-bit data. So here your RP can be BC, DE, HL or stack pointer also. If I say B, what is the meaning of it? If I say D, it is D. If I say H, HL. Here 4 variants are there for this single instruction. Load immediately. For example, if I say, let's do one example. LXI B comma 3040. What happens? Then here it will treat this as a data only. Whether you use it for address or not, it is a different issue for computer. First opcode you should store, then 40, then 30. So it will do opcode fetch, then what? Memory read, memory read. Then your BC will be copied with 3040. It's not memory here. It's not. There is no memory concept in this question, in this representation. Later, you may use this as a memory or sorry, what we call address. That is a different case. So now your C will be 40 and B will be 30. Okay. So this is what happens for LXI. So LXI may 1 minute. So in LXI, what are the variations we have? Let's see. I mean, what is the times taken, everything. Please understand, I am saying that Rahul, okay, this instruction is used to store a register pair, load a register pair. You use that register pair as address or data purely depends on you. Please listen. After LXIB, okay, 3040, you may use LDAX B, then it will become address. After LXIB 3040, you say add B or add C. Okay, in that case, this will be data only. So computer don't know. It will. You are giving some number. That number is stored in B and C. That is the job of computer. Okay. After storing it, it is you. You are using it as an address or data is purely depends on you. Okay. So please ask all these questions so that your confusion will be avoided. How much memory is required here? 3 bytes. See what add B will do when we discuss in the arithmetic operation. Here I gave it as an example add B. Okay, in that case B is treated as a data. What add B will do is we will discuss it in the arithmetic operations. It will add to accumulator B value. B means 30. 30 is added to accumulator. Yes, it depends on the next instruction. Next instruction may you use that number in any way. So 3 byte instructions, how many machine cycles are required? 3 machine cycles are required. What are they? Opcode fetch plus 2 memory read, which is 10 T states. And now you people tell me. You people tell me remaining things. Remaining things. What is that? What is the addressing mode? What is the addressing mode? Tell me. What is the addressing mode? Is it a direct addressing mode? No. There is, you are not giving any address here. You are giving immediately data. That number is loaded into the system. Immediate addressing. Operand is immediately available. Your 3040 is immediately available. So lastly, yeah, this anyone can say. No flag effect. Yes, register pair is used to store the number. If register pair is used as pointer, then register in direct addressing. If you are using it as an address, then direct addressing mode. Here you are just loading one number into B and C. Okay. We will discuss all instructions, Anuj, then all will come, CMA, everything. Yesterday I have given the examples, now everything will come into picture. Okay, so you remember logically here, LXI, load immediately the register pair. Here, this code is just for your easy understanding only, he kept this name. It is not for computer, it is for us only. Okay, let me load the next one. LXI is done, then LHLD. Where is John T here today? The next one, see here. Okay, see here. If I can also see here, please listen. And L. You need to load H and L both. If you load accumulator now, one instruction is there to load accumulator. Okay. So accumulator is a 8-bit register, but load HL, H and L, how many registers are there? Tell me. H and L is a 16-bit register. Yes, HL is a 16-bit register. Okay, so you need two addresses. So here, what is the program is like this. Please listen. Let me explain. Let me explain. HL directly. Give me the number, your favorite number. Give the address. Address asked here, Aditya. Why you are giving 8 bits? These thousands are boring. Yeah, give something. Yes, 1678. I like it. Anuj 1678 hexadecimal. Okay, so at this address 1678 and 1679, you have 2 bytes of memory. That may be some 33 random. Okay, so this is the address. It may be your 2000 and 2001, 2002, 2003. Okay, now see here how you write this program is this opcode first, then 78, then 46. 78 and 46. Now opcode fetch, then memory read, then memory read. Who will do this job? Now again, you need one friend. Who are they? WZ. They will only help us. They will only help us, right? So now HL may L is copied with the contents of 4678. That is WZ ka value here is 4678. Now 33 will come. Okay, then H will be copied with its next value. Its next value is what? 4679. 4679, what is the number you are having? 44. Okay, so first value is 33, next value is 44, like that. So load HL with 2 consecutive memory locations whose starting address is given in the instruction. That is what we call LHLD. Here it requires more time. Why? This is a memory read. This is a memory. Okay, here 1 minute. Yeah, I am telling that only. Here your address bus will be WZ. Here address bus will be WZ plus 1. Okay, so Z will contain this. Z will contain 78 and W will contain 46. Clear what? Shall we proceed? Shivam, what's happening here? Already I explained the same question in today's class only. You are concentrating or you are coming in between? You are there from the beginning of the class? Beginning you are there. You are doing any multitasking? No, yeah. Someone will answer you. Everybody here? I already gave the answer. You people tell me. What do you understand, Shivam? Please tell me. BJ, WZ are the temporary registers used for this purpose only to store anything, and BC, DE, HL may be used by user for another instructions, previous instruction. It is a program, you should think like that, not only this instruction. In this big program, BCDEHL already used by someone else, or maybe having some data that should not be disturbed. WZ are used for that only. Suppose you want to swap A and B. A contains 40, B contains 20. What you take? One temporary register you take. Take T equal to A, that is 40. Then make B equal to T. Then what you do? Sorry. T equal to A. Then A equal to B. Okay. Then B data will come. Then B equal to T. Like that you do the swapping problem. Na? Similarly, Udit, if WZ are accessible to you, you are writing some value in that in the program, but internally computer also using the same thing. So the data will be overwritten or not. That's why they are not accessible to the computer. Computer needs something to do its job. WZ are computer assistants, not for you. Okay, you cannot hire computer assistant. Okay. Aditya, you tell me whether it is you are reading or writing into the memory. Tell me. Tell me, Aditya. Where you are writing, man? You are writing in the memory or L and H? No problem, Shiva. L and H means memory, write or read. L and H is not memory. For us, memory is external memory only. Good. So understand. Someone asked me, PC is updated only during this period. Here PC will be 2003. After this instruction, PC will continue with the 2000. Okay. Let's move. Sorry, I need to give you these details. Tell me. You people tell me. Again, please understand. Don't say it is 5-byte instruction. Only this part. Excuse me. 3-byte instruction. Then very good. Very good. 5 machine cycles. And then opcode fetch, 4 memory read. 4 plus 12, 16 T states. Wait, wait, wait. What is the addressing mode? What is the addressing mode? You are directly loading the address. Why indirect here? There is nothing indirect here. Directly address is given in the instruction itself. Direct addressing mode. And no flags affected. No flags are affected. Direct may, please Amitabh, direct may address is given. From that address, computer will copy the data. Immediate may, please don't talk, just wait. Okay. In the immediate, what happens? Immediately you are giving the data. I will show you. See here. Here, whatever you are giving, computer is going to that place and taking the data. This is called direct addressing. Directly address diya. Address se data we are taking. Now, let's see LXA. Here, whatever you are giving, that is immediately loaded to the BC. Here, this is immediately loaded to BC. But here, it is not immediately loaded to HL. From here, you go to address and there you load the HL. Amitabh ji, is it clear now? Yes, I have considered now 1, 2, 3, 4, 5. 5 cycles are considered. It is your computer time only, na? We will definitely consider. Next, I need to load. If you have load, you will be having store. store HL pair directly. Ask if you want to ask. Okay. You want me to ask? Just wait up to the completion of semester. I will give you, just wait for some. I need to clear a few things, then definitely I will give you very good questions. I mean, I cannot frame it based on this, so that's why I'm waiting. It will be more instructing, otherwise it will be confusing. Again, I need to explain so many things, then only will be able to understand the question. So I am just giving you basic. Have patience. Have patience. I am making your basic strong like anything. Okay. On that strong, you can build any building. So have some patience, listen, understand the new things. So the next one. So please understand. Compare to first instruction. Compare to first instruction. Now you are habituated to this. Compare to first instruction, you are habituated to this. Now you are able to logically analyze the instructions. You have that is started in you. That is started in you. So that's why I said you need not remember anything in the microprocessor. I will make you remember. Lastly, I will tell you what to remember, what need not be remembered automatically. Logically, you can remember. That's why it's a coding name. That by seeing the name, you recollect. By seeing the name, you can recollect. Okay. SHLD, store HL pair directly. It is that is the why it is called a mnemonics. Okay. So SHLD. So store HL pair directly. For example, you give same some, I think Sora has given 4567. Let me take his number. Which you are little late. Already used. Yesterday trapped. Store HL pair directly with the number 4567 address. So computer 4567 per jayega. It will go there. Some, what is this? You call garbage? I call initial. Okay, so computer HL. Okay, assume H is having 40. L is having 50. Initial. So let's take this example. So first computer will do code fetch, memory read, and again memory read. Same, our WZ registers will help. Then here memory write. That is L content will be copied here. L is how much? That is L will be given to 4567. H will be given to 4568. That is plus 1. So another memory write, that is 40. Okay. So here this is what's happening. So here I need not give you more explanation because you became expert now. This is a simple, just last two parts are changed. Now, yes, you see this only. From here you are reading or writing. This is only your memory. Even register is also memory, that is internal, not external. It is how many bytes instructions? 3 bytes. How many machine cycles? 1, 2, 3, 4, 5 machine cycles. And what is that? Opcode fetch plus 2 memory read plus 2 memory write. 4 plus 6 plus 6, 16 T steps. Right? So then what is that? Direct addressing. Very good. And no flag. Lallu is waiting for flags. Just wait. 2 more instructions, then we can affect all the flags. Okay. So this is also done. This is also done. Right. Last, one more instruction in your data transfer group of instructions. Data transfer group of instruction. What is the another instruction we are having? Let's see. Two more are there. What happened? This is only data transfer group. You have arithmetic group, logical group, okay, branch transfer group, machine control group of instructions. So many are there to trouble you. Okay, but yes, but you need not worry much about those things. It will be logical only. You can remember happily. Just our mathematical operations. So now let's see. Move immediately the 8-bit specified in the instruction into the memory location pointed by HL list. It is the same. Why I loaded this here? No, this is correct. Not. So listen here. We have seen move r comma data. Move r comma data is register is directly copied with the 8-bit data. This is a little different one. What is that little difference? Lagging. No lagging here. I have stable connection. Wait. I will show you. For your kind information. Okay. See, I have 3 connections. Okay, all are working. So sometimes one connection will definitely come lagging. That's why I will change it. So let's move. You know one thing. What we can say. Some few classes I faced like this. I bought some 4 antenna modem, good Wi-Fi connection with 50 Mbps, but in that the class is lagging. I just simply used the Wi-Fi hotspot from the mobile. Class is very much good without lagging. So this will also happen, sir. Not Geo. Geo once I tried. This Airtel also I tried. Okay. So let's discuss here. Listen here. Here. Listen. Theory not failed. Practical failed. They are not able to deliver the services properly. Okay, so let's see how to do this one. Okay, now for example, I have HL is M means HL by default. HL is already having 2300. Assume HL is having 2300. Okay, I say MVI M comma Y23 same number. Let's take. Give any number your wish. Wait, number 8-bit. Yes, Sumit won the match. 56. I ask number. Okay, 8-bit here is my requirement. One more. 78 deep. Okay, deep one. But it is garbage. Okay, now what happens? The content of the memory location pointed by HL is copied with 56 hexadecimal. So what is that? M means HL register pair. HL is containing how much? 2300. Here we write the number whatever given in the instruction. So first we do opcode fetch, then you do memory read, then you will be transferring this to whom? Memory write. That is, it will become 56. Okay, so 56 will be given here. So here, what is this? How many bytes? 2-byte instruction. Next, 2-byte instruction, 3 machine cycles. Opcode fetch, memory read, memory 10 T states. Okay, what is that? I forgot. What is the addressing mode? Here two are there. Here two are there. Here immediate is there and HL is used. HL is used. That is pointer concept is also there. So in this question, both are correct. Immediate and also register indirect. You are immediately loading the 56 and also you are using the pointer concept also internally pointer concept is also used. HL is being used to do this job. No flags affected. No flags are affected. So that is about your move M, 8-bit data. Right. Let's move on. Let me upload the next. And who will use it? I mean, which register will be used for doing this job? Only one. WZ is not required. Only Z will be used. Only Z will be used. So if examiner give you both the options, so which one is to be chosen? Okay, keep it as a first choice according to examiner. Because even you understand the subject, you should satisfy examiner also. Why 2 byte lucky? This is 2 bytes now. 1 byte for data, 1 byte for opcode. So if examiner give you both, because it is immediately loading, you take that immediate as the first choice. But technically both are correct. So let me move to the next one. XCHG. The next one is, where is that? Exchange. One minute, Alicha. Okay. So now here, yeah, the content will be given to Z list. W is not required. It is given to Z. I have given na. What is your doubt, Alicha? Who will go to 2000, 3000? H and L will. Any doubt in this? Please tell. Z is used. What is your doubt here? Out of W and Z, Z is used. Okay. If this is a manufacturer choice, you can use, but processor cannot use. Processor should not left with ambiguity. Processor should not left with ambiguity. When it is a choice, they will give one thing. It is lower order. First take it that. Second one, it will generally keep the first one is always to Z. Second one is always to W. Like that, they will design it. Okay, processor ko ambiguity, you should not keep ambiguity to the processor. You are asking questions good, but in a wrong way, I think, Alcha. So ask clearly. So one confusion here: 8-bit data is moving to 6-bit, 16-bit HL. No, Chanakya. Please tell me, Chanakya, you are there in the class from the beginning or not? Okay. So now see. This is the 16-bit address. In this address, data will be changed. Data is 8 bits only. 8-bit data is copied into 16-bit is the address. 8-bit is the data. That is the data pointed by HL will. Oh, good. So the last one in your data transfer group of instructions is HL. Exchange HL with D. That is H L is 3040. D is 5060. If I say XCHG, single instruction, single line, then what happens? HL will become 5060. D will become 3040. Internally exchange hota hai. It is an internal operation, not an external operation. Why internal? It is exchanging only registers only. It is exchanging only registers. Wait. So here you can see exchange only opcode fetch. What is that? One byte instruction. No variations in this. No data is there. Okay. No. Next. What is this? No, it is fixed by what we call manufacturer. He gave this option only for HL and D. Okay. Then only one machine cycle, that is opcode fetch, and 40 states. Next, your register transfer, data is transferred between register address, and no flag. Hurry up. Let me write it. No flag. Why we use to swap the data within less time. Suppose you want to exchange the data between two registers, swapping required. Okay. Then normally if you use move operations, it requires more time now. If you write a program for this directly, move, okay. You should take some temporary register C comma H, then move. What is that? C is copied here now. Then H comma D, then D will come to H. Like that, you should write a big program. It requires more time. So that what is that manufacturer has given us one direct instruction with less time. Because you can save opcode fetches in every case. Right. Let's do one more thing. Total, I think 13 instructions will come. Just 1 minute. So is there any fetch execution overlap required here? Yes. Yes, because here execution is not shown. Like memory read part, whatever you are having, that time we have not considered. Na? So here a few is there. That is T1 to 2 of next instruction. There you will get this job done. What is that? Your L is copied with E. Yes. And H is copied with D. It will take the help of some temporary register like chat, no doubt. If you are having address and the contents of address, we keep the bracket. Here value only, na L value copied to H value copied to E. That's all. L value to E value to H. Okay, Ruchita? If it is a address is given, then we keep the bracket. So it's showing that the number is not copied there. Okay, these two will happen in the T1, T2 states. Why reverse here? It is a bidirectional. Whether you write H to D or D to H doesn't matter. It is exchanging both. It's a bidirectional arrow. If you are comfortable like this, you write like this, no problem. Your happiness is also my happiness. What is 2-bit? I didn't understand on it. What this instruction will do, whatever there in the L will be given to E will be given to L. That's all simple. Fetch, execute, overlap. It is happens in the next instruction, first two states. This job is originally done because 40 states are required to read the data of code fetch to understand only. To execute, extra time is required here. That time is another 2 T states are required to do this job. That is L co give this L data to E data to L, H data to D data to H. To do this job, you require extra time. That will be done in the next two machine cycles. While it is doing its fetch, this execute will be happen. Okay, what is your doubt, Aditya? Now tell me. Next two states mean next instruction which will happen. Next instruction will do its fetch. Address bus is copied. All those things, all those stories same. Parallelly, this job will also be done. Okay. Any doubt, please ask. So now let us recollect all the things we discussed. I mean, revise. Okay, because after reading these instructions, it is quite what we call common to confuse or think. Already negativity will start in your mind whether I will remember these many things or not. Anuj, your doubt is cleared or not? So now I don't want to start this data, what we call arithmetic group of instructions. Instead of that yesterday DPP is there now, we will try those questions after revision if time is there. आज नींद में instructions आएगी. Yes, people, please leave. I leave at 9 only. I am saying before 9, whatever the time is there, na, that time. So we can enjoy the weekend, don't worry. Tell some story. You know about me. Don't know. We will discuss on special class instead of this. Okay. Because this later some people watch what we call recorded, then why to waste their time? कल टेस्ट है क्या आदित्य? मेरा सब्जेक्ट नहीं ना. अच्छा भोगले का ओके मेरा सब्जेक्ट है तो आई नीड टू अपलोड द क्वेश्चंस नाइट दैट्स व्हाई. I don't say the names, Ritik, but I can say I took actually hardly 30-40 days only. Then I prepared self only most of the time. Uh, instead of uh, instead of coaching notes help me more. In the sense, doing the questions, my confidence increased. As you said, instructions will come in your need, na? Same when I prepare also, I used to get problems in my questions. That's why I say while you solve, okay, automatically your confidence increases. That happens to me. That happened to me. Which is how you project you Amitabh. Yes. Yes, get criteria pure can publish. There are some journals where they will accept easy. We should give some dedication on research to publish it. No, not like that. MS takes some 6 months extra. That is the only difference. Otherwise, it is good. Everywhere. No, no necessary courses for no 90%. Over a period of time, at fourth year, if it and 100. Okay, there is no 70% is done, no 80% is done, no 90% is done. Okay, if you get the idea immediately, you read n number of sources. Even you study for 1 year also, you may not get any single idea. Over a period of time, at fourth year or somewhere, you get some idea. Then your result starts coming immediate. It doesn't mean that all these things are weights. All these things are necessary to go to some level. Then your results will come. Triple IT, Aditya, you should do VLSA or you should do computer science. Then only it will be useful. In Triple IT, that option is there. You want to do MS in CS, so you can write exam in CS. Then you can move R1, comma R2 is our instruction. Okay. Move R1, comma R2 is the instruction. You should start speaking. Okay. How many? What is the addressing mode? Otherwise, I'll write here. Let us just revise this. I mean, I'm not teaching you new. Okay, just to make this table and leave. Let me make this table and leave. Instruction. What is that? Addressing mode and bytes. Okay, machine cycles, T states. Like that, let us make one thing. Okay, so if you say one by one, we can finish and we can do. In fact, this much size also not required. So let me complete this table first. I think he went out. I mean, just to opposite of him. That's why it is very silent now. Okay, he started shouting. He's there. No classes. He is very. I think 4 5 years old. I think means at this age why to go. I mean, I don't believe now he need to study anything even in online. Just let's have some fun. Okay, right. So now move R1 comma R1 addressing mode is you just keep commenting. Okay, keep commenting, keep saying your answers. I will also fastly write it. Just fastly we can finish and we can. It is a register addressing mode, 1 byte instruction, 1 machine cycle, that is opcode fetch only 4 T states. Finish. Then move R comma M. It is register indirect addressing mode, 1 byte instruction, 2 machine cycles, opcode fetch plus memory read. It is where is the addressing mode? Register indirect. So 70 states. Okay. Move M comma R also same na. 1 byte. It will quickly revise everything. That's why I'm doing this. Okay, 2 machine cycles, opcode fetch plus memory read. Next, MVI M comma data. It is immediate addressing, 2 bytes. What are they? 2 machine cycles, opcode fetch, memory write, read, 70 states. Right. Next. So see how easily you are able to remember. Now what is that? Let me write all instructions first. LDA 16-bit address. STA address. Okay. LDAX RP. STAX RP. Okay. LXI RP comma data. Next, LHLD address, SHLD address. Next, MVI M comma data. Sorry, one is missing. Let me particular. Just 2 minutes, I will. Sorry for that. Okay, so let just pin it. MVI R comma data. This one is wait. I'm sorry. Wait. Just wait. Hmm. This is MVAR command. Now tell me this. What is the addressing mode? Direct. I'm writing simply D. Okay. This is also direct. This one register indirect. This is register. Register indirect. LXI na LXI means immediate. Okay. LHLD address direct. Direct. Here register indirect. Okay. This job. Next here this is 3 byte. 3 byte. 1 byte. 1 byte. 1 byte. Next data. Data means LXI 16-bit data na, so 3 byte. 3 byte. 2 byte. Okay. So here we can skip this because we have already discussed. Why to waste the time now? Any doubt? Shall we make all these things or leave it? Fourth one, MAR comma data. Register comma data. I'm not saying MAM comma data. M comma data may you have 3 machine cycles: opcode fetch, memory read, memory write. In that case, 10 distance. Anything else? Any wrong in this? Got it? So you can fill this table. Okay. So if required, Monday we start. I will make this table in the Word file. I will upload it if required. Okay. Good. So thank you. Bye bye. Good night. Enjoy your weekend. Bye.